I'm Ines Feng. 中文名係馮又嫦. I'm now a professor of atmospheric science at the University of California, Berkeley. At MIT, I got my undergraduate degree in mathematics, and then I got my graduate degree. It's not a PhD, it's a Doctor of Science, but it's equivalent to a PhD in meteorology. But for me, it's not studying the weather, but studying how the atmosphere works. So I went from studying mathematics, trying to figure out traffic flow, when there's a red light, there's a shock wave coming, and writing equations for that, and then learning to write equations for other phenomenon, and then trying to look at hurricanes. For me, studying the atmosphere was interesting because, I grew up in Hong Kong. Typhoons. Okay, typhoons as a child was bad because I couldn't go to the beach, but typhoon was great because I didn't have to go to school. So science seems like the logical thing to do, right? Mathematics to me is elegant. There's an equal sign, okay? Everything is calm, there's a balance. The left-hand side equals the right-hand side, so I really liked it. All the equations I learned, the mathematics I learned, I can write equations for the clouds. I can write mathematics to explain the cloud structure in a typhoon and a hurricane. And that was very useful because when the hurricane actually came to Boston, when I was a student, I know how many minutes I have to sit in the coffee shop, and then how many minutes I have when the rains lessen, and then I can run. It was very useful, but I couldn't predict the weather. I couldn't do anything. But I was studying mainly the mathematics of how the system works. And then from the atmosphere, for me to go. From the atmosphere for me to study other aspects, the carbon, the vegetation. Basically, I'm now studying the whole Earth. Okay, so basically, I also like puzzles. So for me, it is now like I'm playing puzzles. Nature is just so much smarter than we all together could be. So every time I think I've solved a problem, nature gives me a new problem, and that I thought I had solved it already, but nature says, oh no, wait, okay, here's a new problem, you're not done yet. So I'm really having a good time. You have to look at me, right? I have white hair. When I entered MIT, it was the era where unmarried women under the age of 21 had lived in supervised conditions. So a lot of whether MIT or any school could accept more women, depending on how much dormitory space there was. So MIT, the year I was there, in my class there were 75 women and among 1,000 men, and that was the largest class that they had accepted. Now it's over 50%, but at the time it was 75 women. But in the end, it doesn't really matter, right? You go to class and you sit there, you don't talk to anybody, you just sit there and take notes, okay? You come back, there's a whole dormitory of friends. And then when I went to graduate school, I think you might know, I'm the second woman PhD from my department. But it didn't matter because we all work, right? You all do your work, you all do your homework together. We all went to lunch every day at 11:30. The people my office mates, the people that I associated with, we all talked the same thing. Nobody said anything that I did. We had several international students. The different places I've been and the different people I've interacted with, it's been really enriching. Okay, different people have different perspectives, and you see how you can learn from those different perspectives. And so it's so much easier. It's tougher for me to switch between Cantonese and English where I am, because very few people speak Cantonese where I am. But for the science, now I'm studying the ocean, I'm studying the land, I'm studying I'm studying how plants work. Everything is tied together. We live on one planet. And so this is really exciting to me. Well, science is what advances our civilization. Okay, so this is, I work on climate change, but that I didn't work on climate change because it is a problem. I just wanted to know how the climate works. So one thing leads to another. I don't, it's not like I solve problems. I don't starting out solving problems. That's, okay, I just want to understand something. Okay, I want to understand why the rain falls over here, over the Amazon, and not over the Sahara Desert. Okay, I want to know why there are typhoons over here and not over there, right? I want to know, it's always why. When I was a child, they called me difficult because I was asking questions all the time. Okay, so there is no way you can predict where the new science questions are. If I'm really smart, I would have solved some problem I started out with. I'm not that, but if I were really smart, I would have solved the problem. Then what? So as a young person, you have to have an open mind. Very important to build the foundation. So take biology, take chemistry, take physics, take math, take literature, take philosophy, take whatever you can, build your base. Because that's the foundation upon which you can build bigger things. Okay, so I started not knowing, I'm still struggling to learn biology. I was more in the physics and mathematics side and not in the biology side. But new technologies come along and you have to be prepared, right? New things come along, new ideas come along, and if you don't have the base, it is difficult to build on that. It is, we don't know what the future holds. We don't know the direction. We don't know, the iPhone came just slightly over a decade ago, right? There's no way I could have predicted that would happen. There was no way I could have predicted the drone or the Zoom or, any of the things that we're using. And we adapt to it, but that means that whoever is working is building always the fundamental. We always, where I am, we always say, go to first principles. Build up your first principles, those, and then you can address new questions.